Hello, and welcome to today's activity. My name is Joseph Hebert, and I am a student at Oregon State University studying chemical engineering and chemistry. I will serve as your guide for this activity where you will be able to make your very own homemade battery out of items you may have lying around your home. Let's get started. Before we begin, we must first understand how a battery works. All materials on Earth are made up of tiny little particles, one of which being an electron. Electrons carry charge with them, which we can use to power our phones, computers, televisions, and any other electronic device. Some materials have lots of electrons, so much in fact that they would rather give up or donate their electrons to another material. These materials are scientifically referred to as anodes, but for our sake, we will call these materials charge givers. Other materials have much fewer electrons and are looking to obtain or accept electrons from another material. These materials are scientifically referred to as cathodes, but for our sake, we will call these materials charge takers. When a charge giver and a charge taker come in direct contact with each other, all the electrons from the charge giver get taken from the charge taker. This happens very fast, all at one time. However, through some clever engineering, we can separate the charge giver and the charge taker so that they are not able to exchange their electrons all at one time. We can then connect the charge giver and charge taker using a metal wire to an electronic device such as a light bulb. The electrons, which cannot get through the separator, are then forced through the metal wire from the charge giver through the light bulb or electronic device before finally reaching the charge taker. Now that we know a little bit more about how batteries work, we can go ahead and build one ourselves. It is very important that you work closely with a parent or guardian as to ensure your safety and the safety of those around you. The materials needed for this experiment are aluminum foil, which will act as our charge giver, activated carbon, which will serve as our charge taker, paper towels, which will act as our separator, any metallic wire, preferably made from copper, and a salt water solution, which will play the role of an electrolyte. While I did not discuss the role of the electrolyte, think of this as a greeter, introducing the charge giver and the charge taker, letting them know that they are there. I will now walk you through the experiment. Hello again. I hope by now you have been able to collect all the necessary materials to complete this experiment. Lying in front of me, I have a cutout piece of aluminum foil, which will serve as our anode or an electron giver, a piece of paper towel, which I like to have my paper towel slightly bigger than our electrode giver, our anode. The paper towel will serve as our separator. I also have in front of me 2 copper wires. As you notice, there is a wax coating around the outside of my wires. I have gone ahead and sliced off the end of the wire, removing the wax coating as to expose the copper. This will allow for the copper to conduct electrons. I also have in front of me a 1/4 cup of cathode material or activated carbon. If you have an aquarium at home, you might already have activated carbon. I went ahead and got my activated carbon through Amazon. You can also find it at any of your local pet stores, any store that sells aquatic materials. I also have a tablespoon of plain old table salt, as well as a cup of warm tap water. This will serve as our electrolyte. As I stated in the presentation, the electrolyte serves as a greeter, introducing our electron taker to our electron giver, letting them know that they are there. Before we begin, again, I please implore you to get your parents' permission or guardian's help when performing this experiment. As you can see, I'm also working on a towel, for as you know, science can get messy. Let's begin. So, starting with our electron giver, I'm going to go ahead and take a pencil or any other pointing device, and I'm going to make several holes in the center of my piece of aluminum foil. This will allow for the electrolyte to flow through the electron giver to the paper towel and ultimately to our electron taker, letting them know that they are all there. Once we have made holes in the center, I am then going to go ahead and lay our separator over the top of our piece of aluminum foil, and then using any cylindrical object, I just happen to have a soda can laying around, I'm going to go ahead and wrap the soda can or cylindrical object with the aluminum foil and the paper towel separator. This will give us a nice mold for our electron taker to sit in. I'm then going to carefully remove the cylindrical object so as to maintain its shape. And as you can see, our holes line up somewhat on the bottom. You might be able to do a better job than I did. However, this will work fine for our experiment. I'm then going to go ahead and take one of the copper wires that I have exposed and lay it carefully on the inside of our little mold there. Then, taking the activated carbon, again a 1/4 cup, I'm going to go ahead and pour that on top of the wire and into our little mold. And then, kind of like you would a candy wrapper, I'm going to go ahead and cinch off the top and go ahead and give it a little twist so as to make sure none of our carbon can escape. Again, this is kind of like you would see a Tootsie Roll. We're just basically wrapping our cathode separator and anode, or electron taker separator and electron giver together. So now we have formed our little battery cell. Then we can go ahead and make our electrolyte solution. I'm going to go ahead and take the tablespoon of plain old table salt, pour it into the 1 cup of warm tap water, and go ahead and give this a nice stir. Now, it is important that we get as much of the salt dissolved in the water. That's kind of why I like to have my water warm. It helps with the salt dissolving into the water. It's okay if we can't get all the granules dissolved. Our battery should still function. So once you've given this a nice stir, I'm going to go ahead and speed things up for demonstration purposes. We can go ahead, put the spoon off to the side, kind of clear out our space here. And I'm going to go ahead and dunk our little battery cell, remember we have the holes in the bottom, into that saltwater solution. So now we are introducing the cathode and anode to each other. We are letting them know they are there. We are almost ready to start letting the electrons flow through the battery. Now, for demonstration purposes, I've also gone ahead and purchased a little DC motor. This you can find at any little hobby store. You can also find them online. I got mine from Amazon. You want to get the smallest one possible. They're very inexpensive. And again, this is just a little DC motor, and I'm going to use this for demonstration purposes. So one of the benefits of using a paper towel for our separator is that it absorbs water really well. And so we can actually remove this battery cell from the electrolyte, knowing that our paper towel has absorbed a lot of that salt water and is now sitting in there. So now we have a fully operational little battery cell. All we need to do to allow the electrons to start flowing through our circuit is to complete it. So as you know, we have our copper wire attached to our electron taker, which is on the inside. However, it's not receiving any electrons because there is no connection from our electron giver to our electron taker. All we need to do to complete the circuit is then take our other copper wire and connect it to the outside of our cell. Now, if I did everything correctly, we should see this little piece of tape that I applied to the shaft of the motor. We should start seeing it spin. And voila, as you can see, we have made a homemade battery. We are having current flowing through our circuit. As you can see, the motor is spinning. Our electron giver is giving electrons to our electron taker. And we have completed the experiment. Thank you again for participating. I hope you have learned something, and I will see you again hopefully in the future. Thank you.